If you go on the internet and search for something along the line of PDF Convergence Test Series Summary, you will get a whole summary of all the tests. So from here onwards, I'm going to bombard you with lots of questions. The hard part is in deciding which test to use. So hopefully, over time, you will build up your experience, and then you will have a gut instinct of knowing what to do. So when investigating a series, the first test that you should perform is this one here, the nth term test. So if you're trying to investigate a series, find the limit of this. So find the limit of the sequence. If it's not zero, then you know 100% sure that it's going to diverge, and we've seen this in the past. So the first test you should perform is this one here. So hang on. So the first test you should perform is to find the limit of this sequence as n heads towards infinity. If it's not zero, for example, if it's like say 3, then as n heads towards infinity, you're going to add 3 to your whole summation, and then you're going to add another 3, and then you're going to add another 3. You see, in order for it to converge, the sequence itself must head towards 0. Here you're adding 3. If you're adding 3 each time, then the whole summation is just going to get bigger and bigger and bigger. So the first test you should perform is the nth term test, and then over time you will build up your experience, and then you'll have a gut instinct of knowing what to do. The other thing you should keep an eye out on is for something like this. Factorial. When it comes to factorial, something like this is you can simplify easily. So when it comes to factorial, think about, because when it comes to factorial, you can easily simplify things. When it's one thing over another thing, when it's one thing divided by another thing, you should think about the ratio test. So when you have factorials, think about the ratio test, because when you look at the ratio test, you're going to have something divided by another thing. So when it comes to factorial, you can easily simplify this. Okay? And something else that you should keep an eye out on for is something like this. You can see that. Hang on. So if you look at this, 1 over x is the exact derivative of natural log of x. So if you have something like this, then you could easily integrate this. So you should think about the integral test, or maybe combine the two, or well, when you get to something like this, when you see something like this, if you look at this, rewrite this as 1 over n, and then natural log of n. So you can easily integrate this. This is the exact derivative of this. Or when you have something like this, so here you've got, think of it, visualize it like this. Hang on, 1 over natural log n squared. Well, you would then map a function, a continuous function on top of this. So you're looking at something like this. X here, and then you square it. So this is well, you would then reimagine this as this. Hang on. Let me think. So this is like x, and then to the power of -2. So you're looking for something that when you differentiate it, it will then give you this. Well, think about this: natural log of x to the power of 1 notch higher than this, -1. So well, yeah. So when you differentiate this now, it will be this thing goes down here. It will be -1, and then natural log of x, and then the power gets minus by 1, and then you times the derivative of the exact bubble, the derivative of the bubble, which is 1 over x. You see, luckily this is the exact derivative of this, and so on, and then you need to negate this, and so on. So when you see something like this, it's quite easy to integrate. So you should think about the integral test, and remember there are more than one ways of determining if a sequence will converge or if it will diverge. There are more than one way of doing it, so bear that in mind. Okay. So in the next video, I'm going to bombard you with lots of questions, and then you have to decide. The hard part is in deciding which test to use. Okay.